Welcome to the very first episode of Meet the Pioneers. I'm Deep from NetApp. I'm the host, and I have the privilege to have Yianni from QC Ware, and we are going to dive deep into the world of quantum computing. Welcome, Yianni. Glad to have you on the show. Who are you, Yianni, and why does quantum computing excite you?
It's great to be here. Thank you very much for having me. So my name is Yianni. I'm the head of business development for QC Ware. So that means I handle sales, marketing, and product strategy. And quantum computing is really exciting because it's effectively data science on steroids. So you can think of it basically as everything we do today with data science, anything like optimization, machine learning, AI, simulations. Quantum computers have the potential of doing that much, much faster and much better than what we have today.
Cool. I thought that quantum computers were, maybe 10 years into the future. I presume that QC, where the QC stands for quantum computing. So what do you guys actually do? Do you manufacture the hardware devices, or do you do software?
Right. So you're right. We're still not in a place today where we can launch these quantum computing solutions into production, even though they're fully functional. The reason we don't, it doesn't actually make sense to put them into production is because you cannot really get today the performance that these quantum computers are promising, right? That's essentially a future promise once the quantum computing devices become larger and larger. Now, there are different estimates of when that will happen. We're definitely at least 3 to 5 years away. But there is a little bit of caution there in the sense that this time frame is constantly shrinking, right? So maybe 20 years ago, if you had asked someone that very same question, they would have laughed at you. They would have said, basically, there is no chance that we would ever have quantum computing in production. Maybe 10 years ago, as quantum computing labs became a reality and the first quantum computing chips became a reality, people thought that we were a few decades away, right? But today, we think it's somewhere between 3 to 5 years. But stay tuned because the time frame is shrinking. And this is actually where we come in as well to answer the second part of your question, right? So we, as QCware, we build the software and more specifically the algorithms that make quantum computing a reality, right? So the hardware manufacturers, what they do is effectively put bigger and bigger hardware chips out there that can do effectively can do larger can deal with larger problems, larger quantum computing problems. What the software developers like us are doing, we're effectively releasing algorithms that require less and less computing resources to solve larger and larger problems. So these two things come at it from different sides, and when we meet in the middle, that's when we're going to get to essentially practical and production ready and very powerful quantum computing.
Great. Now, when I go and look at your website, I see that you have data science on quantum computers, you have machine learning on quantum computers, you have financial analysis on quantum computers, chemistry simulation on quantum computers. So who are the kind of users that you are targeting with your QCware data science platform?
That's a very good question, right? So there are actually many different industry sectors that are going to benefit greatly from quantum computing. So specifically, we're targeting finance. That's going to be a major player in the future of quantum computing, as there are many different use cases that apply to financial services companies. And just to give a very brief example, that would be something like doing risk analysis and derivative pricing on quantum computers, doing things like fraud detection potentially for things like money laundering, again, on quantum computers, and potentially getting better results and different and faster results than what they're able to do today. Other sectors are sectors like pharmaceuticals for drug discovery, and to essentially target specific therapies, specific treatments for specific patients. And also areas like chemistry, automotive is a very big player, oil and gas. So essentially anybody that's using really tough computational problems and they're really important for their critical business processes, those are the potential winners of tomorrow for quantum computing.
Cool. And so you have a platform called Forge, and you pre-package all the algorithms that you could use, start building your quantum applications today, isn't it?
That is correct. Yeah.
And could you go a bit more details into what are the kind of algorithms that you built into Forge for a layman to understand, and what are some of the applications of these algorithms?
Right. So we're targeting some of these sectors and some of these problem classes we just mentioned earlier. So for financial services, things like Monte Carlo simulation, right?
Mhm.
For many of the sectors, we mentioned things like machine learning. So classification, clustering, all these different algorithms that are very, very relevant for many, many different businesses, right? And also for areas like pharmaceuticals and for chemistry, we're also providing a chemistry simulation molecule. And finally, we're also providing optimization algorithms for things like supply chain optimization, manufacturing, transportation, things of that nature.
Cool. And if I'm a user of the system, so how do I start consuming these algorithms? How do I what is the first step that I may need to do?
Yeah, so we're really targeting two types of users. The first type of user is essentially a data scientist, and it's a classical data scientist. No quantum computing background is required, and effectively for that type of user, we're providing essentially these turnkey implementations of these algorithms. For example, a classification algorithm or a clustering algorithm, so that experts, classical experts in these industry sectors that we mentioned earlier, can start understanding what are the use cases, what could potentially be the impact of quantum computing, can essentially start building the initial skills required to start using quantum computers, identifying use cases and identifying the impact of quantum computing. So that's the first type of user. The second type of user are quantum engineers. So these are experts in quantum computing that know how to code a quantum computer, know how to write these quantum circuits. For those users, we're providing these repeatable, reusable building blocks. And just to throw an example out there, we're providing one thing called the data loader, which, as the name suggests, allows you to load the real data from your enterprise onto a quantum computer in the most efficient way possible. Because quantum computing requires and for the time being has such limited resources, we want to do things like loading data and doing computation with as few steps as possible. So being very, very efficient is critical. So we're providing some of these building blocks.
Cool. And these algorithms, are they tied to any particular type of quantum device?
In most cases, no. So most of these algorithms that I just mentioned actually can be used across the different available commercial quantum computing systems. There is a small subset of optimization algorithms that can only be used on quantum annealers, and that essentially would be the only thing to look out for.
Cool. So using your Forge platform and using your building blocks and your pre-built algorithms, so a user can deploy quantum algorithms on different types of quantum devices. But the quantum computers are not available on your data center, right? So how do you access those quantum computers?
Great. So we actually partner, we as a software company, we just build the algorithmic part, right? And essentially the top layer to give the user access to all these algorithms. The rest in our stack is essentially provided by our partners, partners like AWS, which has a product called Bracket that essentially allows us to connect to multiple hardware, to multiple quantum computing hardware.
Fantastic. So you could use today's cloud services and you could use your Forge platform deployed on the cloud services to access the different types of quantum devices, as well as you could use the algorithms that you provide to get started on quantum computing. That's fantastic. Now, so I mean, there are different types of quantum devices, trapped ion computers, photonics, and superconducting circuits. Do you have any favorites?
So right now it's clear. It's unclear who the winner will be, and we're waiting for our essentially hardware partners to bring bigger and bigger computers to the market so we can solve bigger and bigger problems, right? So right now it's essentially too early to tell who's going to win. It's even hard right now to actually tell most of the time who's ahead. The essentially 3 or 4 commercial systems that are out there pretty much give you access to the same offering.
Fantastic. Great. It was an absolute pleasure chatting to you, Yianni. You can learn more about Forge at forge.qcware.com and details of what we discussed on my blog. Thanks for watching, and watch out for the next episode where we examine whether quantum computing is useful for financial services. Thanks again.
Thanks.